Our search for the first signs of alien life may be coming to an exciting end. Unless you have a wild story about waking up in a cornfield and having to sit on an inflatable pillow for a couple of days, you've probably looked up in the sky and wondered if there's other life out there. Your questions may soon be answered as scientists prepare to explore an extraterrestrial world similar to our own. Scientists have found a world with a sustainable nitrogen-based atmosphere like Earth. It is larger than the planet Mercury and has large standing bodies of liquid, including rivers, lakes, and seas. And to really show off, it has a weather cycle akin to Earth's water cycle. This mysterious world contains the elements needed for life to begin, thrive, and evolve. And this world is not light years away. It is not merely a hypothetical hope of discovering alien life in the distant future. Titan and all its wonders are found in our solar system, and scientists intend to take off to explore its surface and its abundance of potential life in 2026. What will be discovered remains a mystery, but researchers theorize that a cornucopia of life is conceivably on Titan, waiting to be found. The traces of methane makes its complex atmospheric chemistry possible, but where that methane comes from and how it continues to be replenished is a puzzle. In the next 12 years, we will have crucial pieces to the puzzle and potentially our first examples of how life can diversify in our universe. But before we play Where's Alien Fish Waldo, let's get to know Titan, our friendly neighborhood megamoon. Found floating around Saturn, Titan is the single largest moon in our solar system. Ganymede, which revolves around Jupiter, is technically the largest moon in our solar system, but you can't jet ski on Ganymede, so who's the real winner? Titan is an icy world at minus 290 degrees Fahrenheit, with a surface obscured by a golden, hazy atmosphere. If you want to peep at Titan through a telescope, its haze makes it look like Saturn blew a cloud of Cheeto-flavored vape all over it. The golden appearance comes from the methane in Titan's atmosphere, which also makes its ability to harbor life possible. The Cassini orbiter spacecraft first skimmed through Titan's upper atmosphere in 2006. The data returned provided new information on the magnetic field and plasma environment around Titan, which revealed the complexities of the moon's chemistry. The Cassini spacecraft also provided numerous gravity measurements, revealing that the moon is hiding an underground ocean of not exactly water. Let's just call it liquid space juice. Titan's surface temperature is so cold that liquid space juice can't be water in the sense of the whole H2O thing. Scientists speculate that instead, the liquid that fills Titan's oceans, lakes, and rivers is a mixture of methane and ethane, with some heavier hydrocarbons sprinkled in. When we eventually open up Titan for tourism, you can try a bottle for yourself at the gift shop. So if there's no water on Titan, how could there possibly be life? Well, that's where the fun in understanding the diversity of life in the universe begins. Unless you're feeling the firm, the probability of other life forms existing in our vast universe is not much of a question. Over thousands of years of research, humanity, with the exception of people who prefer a pancake Earth, have concluded that our universe is really f***ing big. Our universe is so f***ing big that odds that we are alone in it is really f***ing small. Now that's what I call science. So in confidently assuming that there are other forms of life in our universe, our next big question is finding out how they differ from us due to their biological makeup. The possible life on Titan would be our first crack at the cosmic chemistry code. And impatient scientists like NASA researcher Christopher McKay have begun to theorize how life could exist on Titan before we go up there and get samples for ourselves. McKay theorizes that chemical compounds in Titan's atmosphere could be the source of biological energy when reacted with atmospheric hydrogen. Light levels on the surface of Titan are ideal for photosynthesis, and even though there are fewer elements available on Saturn's BF than on Earth, Simple ecosystems could exist that consume atmospheric nutrients. On Earth, some bacteria can survive on this energy level. And as my grandmother used to say before she was violently murdered by those damn train robbers, where there's a will, there's a way. And McKay suggests that if life on Titan could develop strategies to adapt to the organics of liquid methane and use catalysts like trace metals from meteorites broken apart in the atmosphere to accelerate biochemical reactions, then it could survive the cold temperatures and continue to evolve. You go, tiny amoeba with a fur coat. A+ evolution. The belief that there is life that exists on Titan is furthered by its perceived role on the planet. If we haven't made it clear, Titan is really into methane. Not to the extent that Saturn's other moons need to set up an intervention. Titan just loves its methane. However, as sunlight continuously breaks it down, it's uncertain how it is replenished. A source must be responsible for providing gas, or else it would be depleted over time. But it's still there, which leaves some researchers to believe that a life form could be acting as Titan's filtration system. Now that we know how life is possible on Titan, let's try to solve scientists' next big question and figure out where it might live. To do this, we need to put ourselves in the shoes of alien life and figure out where we would want to live if we were it. However, if life exists on Titan, we're not sure which shoes to wear, as we don't know the stage of evolution life might be at. Could it still be single cells that soak up the atmosphere's energy? Maybe it's swimming around in its yeti fish frog-phibian stage. Maybe the yeti fish frog evolved into two species of intelligent life that continuously go to war with each other in the underground ocean. And then one day these fleshy-looking earthlings show up and tell them that their home is not cool enough to be a real planet, and then they get so mad that they put their differences aside and team up against us with their ice powers. Or, perhaps, life on Titan would appear as a living crystal-like ice, which a team of researchers at Cornell University predicted after running a computer program simulating how molecules found on Titan would act while bumping into molecules of methane at 298 degrees below zero Fahrenheit. To simplify finding out where life on Titan might be, let's continue to generalize the different biological possibilities and just refer to it as life on Titan. Now, as you picture yourself as this generic alien life, we want you to imagine that you're house hunting. And I'll be your over-the-top real estate agent and provide you with different housing options that fit all of your alien needs. Whichever one sounds the most appealing will be your choice and your very own theory to brag to all your friends about. And if your friends aren't into this kind of thing, we'd love to know your thoughts in the comments below. Dr. Lucy Norman from the University of Hong Kong provides 4 different locations where life on Titan may be hiding in plain sight. Our first humble abode is Titan's silicate core. The silicate core is the outermost layer of the rocky core and is probably cool enough for organisms to survive. The utilities included in this environment come with plenty of liquid space juice from the ice layer above, which can mediate a range of chemical reactions. Our second casa of the tour is the high-pressure ice mantle. The ice mantle is a modest frozen shell complemented with fluid inclusions in which microorganisms are known to survive. If microorganisms were present in the early history of Titan, they could have evolved with the icy matrix of the high. Our third stop is a beachfront villa at Titan's subsurface ocean and crust. The subsurface ocean comes with all the amenities that a potential homeowner is looking for. Temperature, pressure, pH, nutrient availability, you name it, the ocean's got it. Our last model is subsurface liquids, which is a great starter home for families. Theories suggest that liquid hydrocarbons could be the basis of life on Titan, playing the same role as they did on Earth. Many great elementary schools are also within driving distance. So, which home sounds the best to you? And what's your prediction on where life on Titan could be? Luckily, you won't have to wait long to find an answer. Set a reminder in your calendar and come back to this video in 2034, when NASA expects to land its Dragonfly drone on the surface of Titan. Scheduled to launch in 2026, the drone will scour the moon's surface for signs of chemical processes that could breathe life into inanimate material. If Dragonfly is a success, it will mark a new chapter in humanity's understanding and relationship with extraterrestrial life.